In this lesson, we're going to see how we convert between grams and moles for both an element and a compound. We've learned how to calculate molar mass, and we can use that as a conversion factor, also known as a relationship, between grams and moles. Unlike some relationships where they're fixed, 12 inches equals 1 foot, that's always true. We see that the molar mass is a conversion factor or relationship that changes depending on the substance. For example, water is 18.02 grams per 1 mole. And just like with Avogadro's number, we can invert that depending on what unit we need on the bottom and what unit we need on the top. But notice that the number 18.02 always stays with the grams because it's 18.02 grams in 1 mole. We're going to continue to use dimensional analysis just like we've been using all along. If we want to end with a simple unit, we need to start with a simple unit. And we're going to use different relationships. In this lesson, we're going to focus on molar mass and Avogadro's number. So molar mass, 12.01 grams per mole. Avogadro's number, 6.022 times 10 to the 23rd things, whatever those things are, per mole. Sometimes we'll use these separately. Sometimes we'll use those together. And we're going to go through several examples to see how to use each one. We've seen this diagram before, and we were just focusing previously on the moles to molecule or moles to atoms. Now we're going to kind of expand upon that and look at grams to moles to molecules to atoms if we're dealing with a molecule, so anything with 2 or more atoms combined, or with an atom where we go from grams to moles to atoms. Because we're talking about individual atoms, there is no molecule to worry about there. How do we use this? Well, if we're going between grams and moles, we use molar mass because it has units of grams per mole. So there's a relationship between grams and moles. If we need to go from moles to molecules, then we're going to use Avogadro's number. 6.022 times 10 to the 23rd equals 1 mole. For molecules to atoms, we saw this in the previous video about using the ratio from our chemical formula. If we need to go from grams all the way to atoms, then we're going to first have to go to moles, then to molecules, then to atoms. I can't go directly from grams to molecules. We have to go in the order that they're listed. We can go in either direction, but has to be in this order. If I'm looking at individual atoms, so just Na, just helium, I can go from grams to moles to atoms. Same thing, I use my molar mass to go between grams and moles, regardless of which direction I'm going, and Avogadro's number to go between moles and atoms of an element. A common mistake that students make is they feel that just because we know both the molar mass and Avogadro's number, we need to use them both. And that's not always the case. Some problems will use them both. Some problems will only use one of them. Molar mass is used to go from grams to moles or moles to grams. Avogadro's number is used to go from molecules or atoms to moles or moles to molecules and atoms, depending on whether we're looking at a compound or an element. To convert from grams to moles, we will use molar mass or Avogadro's number. Molar mass has units of grams per mole, and that's what gets us between grams and moles. To convert from molecules to moles, we will use what? Avogadro's number, because it tells us how many molecules are in a mole. What do we need to use to solve this problem? How many molecules are in 25 grams of NH3? We're actually going to use both molar mass and Avogadro's number because we're going from grams to moles to molecules. To get from grams to moles, we use molar mass. To get from moles to molecules, we use Avogadro's number. Let's look at an example of this. How many grams are in 2.25 moles of H2O? We have 2.25 moles of H2O. We know that the molar mass is 18.02 grams per mole, and moles cancels out. And when we do the math, we get 40.5 grams of H2O. This is using molar mass. We went from grams to moles, no molecules or atoms involved, so we did not use Avogadro's number. How many moles are in 34.2 grams of H2O? We're going to start with the 34.2 grams because that's the number we know. And then we can put grams on the bottom of the next step and put moles on top. We're still using the molar mass, 18.02 grams per mole, but now we've inverted it to make the units cancel out. We cancel out grams and we're left with moles, 1.90 moles of water. How many moles of caffeine, and we're given the formula and the molar mass, are found in a 50.0 gram sample? We're going to set this up just like we did the previous problems. We have 50 grams of caffeine. We have grams in the numerator, so we need to have grams in the denominator of the next step. The molar mass is 194.19 grams per mole. We do the math and we find we have 0.257 moles of caffeine in a 50-gram sample. So A is the correct answer. How many grams of CH4 are in a 2.25 mole sample? Notice that we have the same number of moles that we looked on a previous problem, but now we're talking about a different substance. The molar mass is going to be different, therefore the grams is going to be different. We're still going to set the problem up in a very similar way, but we're going to get a different result. 2.25 moles, we put moles on the bottom and grams on top, so 16.04 grams per mole. Moles cancel out, and we get 36.09 grams of CH4.